Hello, welcome to Module 10. This is deleting and updating data. And it's really sort of two separate topics because I'm going to talk about how to delete rows and update rows using mutations and then also lightweight deletes and lightweight updates. And then I'm going to show you a different technique. By the way, those all cause mutations, which are overall a very heavyweight kind of operation in ClickHouse. And then in the second part of this training course, I'm going to show you a way to avoid mutations, avoid deleting and updating data by, oddly enough, using different table engines. And so we'll talk about the replacing merge tree and the collapsing merge tree table engine and how you can use those to do things like upserts or frequent deletes or frequent updates. And so it's a little bit different than how you would normally do that in a transactional type database. As you can see, Module 10 is a part of our 12-module ClickHouse developer course, and we've gotten past putting the data in, analyzing the data, we've created views, we know how to join our data now, and so now we're getting to the more advanced topics like deleting and updating data. So, let's get started. Let's take a look at how to delete and update data in ClickHouse. And it's an interesting situation because when we talked about parts, and every time you do an insert, you get a part folder. And of course, those merge into bigger folders. The folders, all those column files in those folders, they're all immutable. Nothing can be changed. So if you have a part, let's say it's got 10 million rows and you want to go in and update one value inside one column. Well, ClickHouse can't even do that if it wanted to, like the files can't be written to. So what do you think has to happen? Well, how does that work? Well, as you might guess, the updates and deletes happen when the parts merge. And so it's sort of like a heavyweight operation. In fact, it's such a heavyweight operation that to delete a row or update a row, we actually have the alter table command to do that. And this operation is called a mutation. It's almost like an event because it doesn't happen right away. Yeah, I ran the query right away and the response came back right away. I deleted every row where y wasn't equal to hello, or I updated every row where x was greater than 10. That doesn't happen right away. In fact, there's a table in the system database called mutations, and you can actually track all the mutations that you have and see which ones are running, which ones are done, how many parts have yet to be processed, and so on. And so, it's kind of a lot of effort to do this. And so it's something that you have to be very aware of. Now, hang on, I'm about to show you a couple of alternative things that you can do here, but it's just really important to understand this. ClickHouse wasn't designed for regular deletes, regular updates. So what we've done is we've created different alternate ways to do that. And so like I said, there's this table called mutations, shows you everything that's going on. If you have a mutation that's stuck, you can kill it using the mutation ID. And you can actually, by the way, set mutations underscore sync to 1 or 2 and decide if you want to wait. Check the docs for the values of that. You can wait for the mutation to finish if you're interested. One of the alternate options is using something called a lightweight delete. Now, a lightweight delete has a different syntax. You don't use alter table, and that's very important. That is the difference, by the way. Alter table causes a mutation. If you just say delete from my table where some condition, well, that's called a lightweight delete. Those actually happen immediately. The moment you run that query, you get back a response. Those rows are, at least in theory, or at least in practice, they're deleted. Now, they're not deleted, but they've been marked for deletion. And notice on the little bullet down here, it says the select queries are automatically rewritten. So all your queries exclude the deleted rows. And behind the scenes, ClickHouse has this hidden column that's keeping track of whether or not a row is deleted. Now, what happens is the data eventually gets deleted whenever the next merge happens. And so these deletes can kind of pile up. Now, you don't want to have too many of them before a merge, but it's nice. If you're doing the occasional delete, a lightweight delete is a nice option. It's relatively new. Make sure you're using the right version of ClickHouse that supports it. And we also have lightweight updates. And first and foremost, I should point this out. They're only available in ClickHouse Cloud. You can't use these in the open source version of ClickHouse. But they're super easy to use because you don't change the syntax. You still say alter table, update, whatever. All you have to do is set this property to on, like apply mutations on fly. You set it equal to 1, that enables that setting. What happens is every time you update rows, we keep track of those updates. We have a special way to keep track of all the rows that are updated. And every time you write a query that pulls back those rows, we apply the updates during the select query. Now, you don't want too many of those, obviously, sitting in this special place where we save them all. They're sitting in memory, but we also have them in a persistent way. And so, at some point in time, that can have a negative impact on performance. You want the parts to merge eventually so that all of those sort of cached updates can finally get applied on disk to the actual files. But it's nice because when you update a row, it's immediate. This is a great way to update rows as long as it's not, like too many rows, as long as you're not doing something crazy. Super nice. So check that out. So those are two nice options, I guess. But at the end of the day, you have to ask yourself, well, how do we update and delete a lot of rows in ClickHouse? Because I already said that, lightweight deletes, lightweight updates are super nice. But if you're just doing frequent changes, well, there are ways to implement deletes and updates through a process called deduplication, and where you actually insert the data multiple times. And the newer data that gets inserted becomes like the latest value. We call it the state of the rows, and the older values get deleted. Now, of course, none of that happens immediately, but it's nice how it works. And so it just depends on your use case. Are you doing upserts? Well, there's a table engine that works really well for upserts. Are you doing a lot of updates all the time and deletes? Well, there's a different table engine that works really well for that. And again, it's all about deduplication because you can't delete a row immediately. You can't update a row immediately. And so we do this clever, we use these clever merge tree table engines. Replacing merge tree, I'll show you that one first. Very simple. If two rows have the same key, not necessarily the primary key, it's actually the sorting key. So if two rows have the same sort key, the last row inserted is the one that's the current state. It's great for upserts or the occasional update. Collapsing merge tree is similar. It has the same sort of logic to it of when you insert a row, it's kind of like the last one inserted, but there's another special sign flag that is applied. So the collapsing of rows is similar, but the logic is different. The rows still collapse on the same sort key, but the way they collapse is different. And then version collapsing merge tree is just a special case of collapsing merge tree. And so let me work through these. Replacing merge tree, kind of does what it sounds like it does. It replaces, rows get inserted, they replace existing rows. The sort order key is everything here because that's what dictates uniqueness. In a replacing merge tree table, you'll only have, in theory, one row per sort key. And so in this very simple example, I have this table called duplicate demo. I want to walk through this. I want you to see how this works. This is a good example, and it's best seen by actually looking at the code. It won't take me long to create the table. So if I create this table called duplicate demo, and it just has two columns, X was an unsigned integer, 32-bit, Y was a string. I'm going to set the engine equal to replacing merge tree, which we know in the cloud is replacing shared merge tree, but that's conversation for another day. It's order by, primary key, order by, whatever it is. It's the sort order to be very specific, but here it's the same value. X is the value that's going to determine what it collapses on. I'll just do order by to be very specific. So let me create that table first of all, and then let's put some rows into it. So let's insert into duplicate demo values. Doesn't have to be much. I'm just going to do hello world. This is very much a hello world type example. So I'm going to have a value for x equals 1, a value for x equals 2, and that's it. Only got 2 rows in there. Well, let me add another row. Watch this. So just save a little typing here. For the value of hello for 1, I'm just going to put in goodbye. So in effect, what I'm saying is this row that I've just inserted will replace the row where x equals 1 and the value of the string was hello. Well, watch what happens. If I select star from duplicate demo, well, wait a minute. I get 3 rows, which I suppose makes sense. I inserted 3 rows. I get back 3 rows. But I thought everything I just told you made it sound like the hello was going to be deleted, like this row was going to be deleted and this row was going to be the current state. Well, look, deletes don't happen right away. It's important to understand that ClickHouse knows that goodbye is the current row. It knows that hello is not the current row. It just hasn't been deleted yet because I haven't had any merges yet. Well, do I want to force a merge? No. That's the last thing I want to do. I do not want to force a merge here. There's a way to tell ClickHouse to grab the final result of this. By the way, if you want to know what's happening here, you can see it better from a terminal, if I go over here to the terminal, this one, yes, is connected. You can see that I get back these two boxes. Why did I get back? Kind of looks like two tables. Well, what they really are two parts. Hello world is in one part. Goodbye is in another part. And the reason that I don't see, why I still see hello and I don't, goodbye hasn't overwritten it yet or replaced it yet, is because the merge hasn't happened. What you do with replacing merge tree is you put final after the table name. So from duplicate demo final, at query time, ClickHouse throws out the rows, it applies the logic of the collapsing. And the collapsing happens at query time instead of, what would normally be at merge time. The rows are still there. I didn't delete the hello row yet. Now I can, and I always cringe to show this, but I'm going to do it. I'm going to optimize table, duplicate demo, final. It's going to merge it all into one part. You just can't do this with business logic. That's great that I can merge the table. And what I want you to see with me optimizing the table, it's almost not a great word. I hate that it's called optimized table because it sounds like something you're going to want to do all the time. You're going to never want to do this, pretty rarely. I mean, there are use cases for it. When you're done inserting data, you want to merge a bunch of parts. That's great. Don't use it for a situation where you want replacing merge tree logic to happen. You just have to add final to the end of all your queries. Now notice I didn't, with or without final, the row is gone. It merged into one part and you can see that hello got deleted just like we expected it would. And I have all of that over here on the slides. You can see where I have hello and goodbye and what happens if I use final. All right, so that works well for upserts. Doesn't really delete a row. The row is still there. It's just the last row inserted. Collapsing merge tree is a little bit different. You can update or delete a row, and every row has a current state, which is true for replacing merge tree, by the way. In replacing merge tree, it's simple. It's just the last row inserted. In collapsing merge tree, it's the last row inserted where the sign field or the sign column is a +1. And what you do is, and it's the same logic with the order by key. That's, the sort order key is the collapsing, the value that the rows are collapsed on. So the values that have that cancel each other out, like you can insert a row and put in a -1, that'll delete the row. And then you insert a row and put another, you insert the row again with a +1, that'll be the current state. And so the sign field the sign column is meant to cancel itself out. All right, let's take a look at an example. This is definitely something you want to see as just like the last one. Let's have this table called URL hits, and it's got a string. That's, I'm counting visits to a website or something. So have the hits, have a URL, have the number of visits to the page, and then you have to add a sign column. Now you don't have to call it sign, but you do have to pass it into the table engine. It's collapsing merge tree. And in the constructor, you have to pass in the column that's either going to be plus or -1, and it has to be of type int 8. Oops. And I want to order by URL. So that's going to be what my rows are going to collapse on. So if I insert into URL hits, the last rows that you insert, well, these are the first rows that I insert. But let's say I have an index page and it's got 20 hits. Well, I'm going to put a +1 for the sign column. And let's say the docs page has 10 hits, and that's the same, that third column, that's going to be a +1. And so you can see the values are there, and that's not very exciting. I would expect to see, all of the, the two columns. Well, let's update one. Let's say that, the value has changed. So let me copy this part. And we went from 20 hits to 30 hits. Well, I'm going to cancel the previous row, and then I'm going to use the same key, and I'll change 20 to 30, and I'll put a +1 in there, and let's see what happens. Here, I'll run this command again. Well, now, instead of having one row that it collapses on, the collapsing hasn't happened yet because a merge hasn't happened yet. So now I have 4 rows in the table. Well, I inserted 4 rows. I can see the 4 rows. The collapsing logic will be applied if you add final to your queries. And it's fine. It's perfect. I mean, it's perfectly fine to use final. It's exactly what it's used for. It's what it's meant for. So don't hesitate to use final. Now, you might be able to find some clever way to avoid using final. But keep in mind that if this were to collapse, when this merges, these will collapse. But right now it hasn't happened. One thing might be clever. Notice I passed in the old value of hits. I didn't have to. You don't have to pass in the previous value. If you want to, you can delete a row. The number of hits doesn't have any effect on the collapsing logic. It's just sort of carried along. So if I go to docs and I want to delete that row, I could simply pass in a -1 for the sign. And so now of course I just added another row. It merged. And I didn't even ask it to merge. Somewhere in the background, when I inserted this -1, that triggered a merge, and voila, I'm right where I want to be. So what I want to do is change this 30 to a 50, and I want to show you some way to avoid final. And all you have to do is just use something clever. First of all, one thing is pretty obvious here. The number of hits is always going up. So I could always just grab the maximum value of hits. And that is quicker than using final, by the way. It's quicker for ClickHouse to perform a group by and let me see if I wrote that right. Yeah, perform a group by and figure that out. The other thing is, if you notice, if you look very closely at this table, the fact that I have the old value, I could take 30 times -1, 30 times +1, add them together and get 0. Take 50 times +1. It'd be pretty easy for me to do something very similar. Let me just copy and paste this to save a little typing. Instead of grabbing the maximum value, I could do a sum of the hits times the sign column. Let me see if that makes sense. Yeah. Okay, that's business logic. That may or may not work for your use case. You might not know the previous value. And you might not have a clever logic of using max either. Look, at the end of the day, if you don't have any way to avoid using final, just use final. Nothing wrong with using final. Don't believe everything you read on the internet. All right. And final can actually sometimes be more efficient than the grouping. So try it out and see which one works better for you. Okay, so that is collapsing merge tree. I have all these on the slides. The same examples. I tried to use the exact same numbers and everything so you could follow along in the slides. I'm trying to think of what else I might be able to say. Yeah, you can cancel a row, deleting a row like I showed you with the docs. Here's the clever use of the summing of hits. Here's the, using the max hits as well. Whatever. Just use final if you have to. No harm in that. Again, you can force a merge. Now, don't force a merge, but it's absolutely, what's happening behind the scenes is during the merges. And that's when these things get collapsed. Hey, both replacing merge tree and collapsing merge tree, the logic is simple. The last row inserted with the +1, it's all about the timing. The last row I inserted that had a sign column of +1 is going to be the column that's going to be the current state of the row. With replacing merge tree, it was simple. It was the last row inserted that had the same key as an existing row. It's all about timing. Well, there are situations where timing might not be great, where you might have a race condition. And so what I'm going to show you is if you go to the docs, replacing merge tree has an optional version column and you pass it into the constructor. Now, the example in the docs doesn't have it, but if you had a column that was always increasing, like a timestamp, like if you had a timestamp column, it's not unusual for the version to be a timestamp. And then the last row inserted, you don't have to worry about when the row got inserted. It'll have the value. When you define version, the last row inserted is no longer applicable. That merging logic doesn't apply. When you define that version column, it is the highest value of version that is the current state. Collapsing merge tree is a little different. Collapsing merge tree doesn't have a version argument to pass in. You can only pass in the sign. It has a separate table engine altogether where you pass in the version column. But the logic is the same. The collapsing logic of version collapsing merge tree with the +1s and the -1s is the same logic. It's just that instead of a time thing, which is kind of like a race condition thing, it uses the highest value of version. If you're curious, be sure to check out the docs where it explains all the algorithm in more detail. And so that is how you would implement a situation where you had to update or delete a lot of rows in a hurry. Because in effect, it happens immediately. Now, does the row get deleted immediately? No. Does the row get updated immediately? No. But you can always figure out the state of a row and let the merging and collapsing happen in the background. And it is a very useful mechanism for implementing this. In the lab, the first lab, you're going to do a replacing merge tree. It's very important to understand how those work. And then in the second lab, you're going to do a collapsing merge tree. Very nice. All right. As always, if you have any questions, need any help, clickhouse.com/Slack. Look for us in the ClickHouse Academy channel. Send us an email at learn@clickhouse.com, and off you go. Good luck.